Hey, this is Horner again. So I have a student who's given four pipes, A, B, C, and D. So here's our four pipes. And pipes in B, A and B are open at both ends. Pipes C and D are not. The student takes pipe C, I'm sorry, the student takes A and B and actually puts them together and makes one tube that looks just like this. They want to know, will the tuning fork resonate at the combined AB pipe? And absolutely positively it will. Notice they gave you the equations, okay? We're going to put these into the calculator because that's really super important, but uh, you really need to know these. You need to memorize them because they will not always give them to you. So here it says justify your answer by discussing any boundary conditions of standing waves in a pipe. Include diagrams to aid your explanation. So why is it that it resonates? Well, if you notice on the end here where you're going to connect A and B, these are both antinodes. And so since they're antinodes, they will fit together really well. In fact, when you put them together, this is that area right here where we've put this end to this end, and it just continues making an antinode. So that is why. Justify your answer using an open pipe equation above. So here's the open pipe equation. We're going to rearrange this so we get the length of this entire pipe. We add the two lengths together, and then this equation means that you have to take the n values. So remember, n is an integer, and you'd have to add those together also times the speed of sound. Remember, these numbers tell us the harmonic. So really, if you think about this, n is equal to the harmonic number. And in this type of tube, we're looking at the nodes. So remember, the nodes help us with that harmonic. Next thing that we're going to do is we're going to say F is constant since the tuning fork and speed of sound are the same. So if you add these L values, then you also have to add the N values. So my L values here, when I add my N values, I'm going to go 1, 2, 3. So here's 1, 2, 3. So this goes from being 2 and 1 to actually going to 3 altogether. And so that will give you a totally different sound. The student removes the caps that close the ends of pipes C and D and then connects those pipes together to make a single combined pipe. So what I'm assuming that they're doing here is they want to know if it'll resonate. Yes, it will. They are going to keep this cap on. Okay, so this is a little bit misleading. I really think that you've got to leave this on. If you do that, the closed end is a node, and then as it travels through, when it gets to this point right here, which is the connection, that also is a node, okay? But because this is a closed-end pipe, we have to go back up, and we have to remember that it is Fn is equal to Nv over 4L, okay, so that changes to 4. But the more important thing here, and the thing that they'll catch you on, is in a closed-end pipe, the harmonics go first harmonic, so first H, third harmonic, and then fifth harmonic. And remember, for overtones, that's fundamental, first overtone, and second overtone. So this is really tough because you got to remember that in a closed pipe, it's first harmonic, third harmonic, and fifth, not like it is for this one. This one would be first harmonic, and then second harmonic, and then third harmonic. So this one is at the third harmonic. This one is not. This one is at the fifth overtone. So you have to be really super careful here. Okay. In this case, both the N numbers are odd. When you add them together, you get an even N number and a standing waveforms. So you need to have this equation that you've modified. You need to say that you need to add the N numbers. So here we add the lengths. Here we add the N numbers, and that makes it an even N number. And that standing wave then forms within the pipe. And that is the end of question number 3.